Hello, everybody. So, today we're discussing tree support systems and lightning protection. Now, I will gladly admit that this is not my specialty. So, I have taken this lecture off of Illinois Arborist, and it was delivered by Don Rapolo from Davy and the Care of Trees. And so, I took the majority of his work and have just adapted it slightly. So, thanks to him. And hopefully you enjoy it, because it's definitely not my specialty, but I'll do my best. So basically, in terms of the idea of tree support and protection, why do we want to install support systems is going to be the first thing we talk about. Then we want to talk about the standards for support systems. What are they? And a lot of this chapter deals with not so much just terminology, but more just very specifics in terms of the actual hardware and the parts of the system and how they're used. Different types of support systems, so dynamic and static, and then the installation practices and common mistakes. Those are going to be kind of the focal points. So the first part, in terms of why do we install support systems, is pretty easy, with the idea of we don't want something like this to happen. We've got to be cognizant that eventually, over time, trees will give up, and trees will have issues, and they get old, and then they fall apart just like we do. And so, in knowing that, we've got to be ready for that to happen, or we've got to really just understand that if something like that's going to happen, we've got to have another plan, or we've got to have another plan of action to try and prevent that from happening. And that's where, for older trees or trees that we really want to keep, or they have high value, we're going to come up with these tree support systems to try and prevent something like this from happening, or at least not really prevent it. It's not going to stop it, but more the idea that we're going to prevent the catastrophic part of it, right? We don't want this whole house to be destroyed and all that, but if we limb up our trees and prune our trees properly, and we have cable support systems in place, and we do all these things, we can probably limit the amount of damage that will happen. And so, the three biggest reasons why we should cable trees. The first one is the one that the book really focuses on, which is the weak branch union. So usually this happens whenever you have codominant stems, like we see in this bottom picture here, and because you get included bark, and you don't get that nice bark ridge, and you don't get. You have a weakened union, so you have it to where the two trees, or the two stems, have come together, and because they've come together, you don't get a good seal there. Basically, you just end up with included bark, and because of that, it's always going to be weaker than if there was one leader, or even a leader and a branch coming off of that leader. It's always going to be weaker than that, because you don't get that. The way we would with a branch, where you get the branch bark ridge, and you get the nice branch collar, and you get all that that bark protection zone and everything set up there, where you've got everything is just set up right for the tree. The tree really feels that that a branching off is not a weak point. It's a strong point, whereas codominant stems, though, is a weak point. It doesn't. The tree doesn't have a good way of dealing with codominant stems, and you end up with included bark and a weak point. Another place you'd want a cable is long, heavy limbs. You can see that in this top picture here, where you got these big, huge limbs, and eventually you're just going to have so much weight off of one side of the tree, or off to one point of the tree, that you're going to put a lot of stress on the tree. And then a third way would be if you have to support entire limbs. So if you've got just really, the whole limb kind of needs to be guyed up, or needs to be held held up or held in a certain way, that's another reason. In terms of the appropriate standards, so we've got both the ISA best management practices for tree support systems, and then we've also got the ANSI standard practices. I think it's A300 standard practices supplemental support systems. Those are your two go-to guides when it comes to the appropriate standards. So in terms of tree support, we've got cabling, bracing, guying, and lightning protection. There's going to be those are all different types of hardware that are going to end up in trees. Your hardware installation will cause wounds, so you really have to be understand that there's probably going to be decay. And it's really important to make sure you're putting it in a sound part of the tree, because this whole thing doesn't work unless where we're putting the cable adds extra support. Because if we don't put the cabling and the hardware in the right place, we put it in where there's decay or where there's rot or anything like that, it's not going to work. It's not going to add any extra support at all. The hardware provides extra support by limiting the movement of the limbs. And it's basically the movement of the limbs. You know, if you have a big limb just kind of sticking out and it's just doing this over and over again, it's that stress here that's going to eventually make that limb fall off. And so the idea of preventing that movement from happening helps to reduce the risk of failure and at least extend the life of the tree. But like I mentioned before, hazardous trees cannot be made safe by the use of cables. And what I mean by that is the idea that we can't prevent any of this stuff from happening if the tree's doesn't have any strong wood forests or any good part where we're trying to put in the cables. If it's not sound, if it's not solid, if it's not going to give us a good place to offer support, then none of this is going to work. So in terms of cabling, cables are installed to support limbs that have weak branch unions, codominant stems being the one that we deal with the most. They're installed to support heavy limbs. You can install them to support weak wooded species. So you know if the tree is a softwood tree that has issues with breaking or splintering off or losing limbs, that would be another use for it. It can support limbs that may pose a threat to people or property. That's kind of a bigger one, especially if you really like having this tree next to your house, kind of like we saw in that one of those opening slides where the tree fell all over the house. So that would be a good place where we'd want to do some cabling just to make sure, because we know it's hanging over our house, but we love this tree, so we just want to add in a little extra support there to feel a little bit safer about it. And then sometimes in the support of whole trees, and you can see that especially where I see that is with some young trees, which I don't think necessarily for me that they need it, but you'll see some guying done with cabling and guying done with younger trees as they start to grow, because they're trying to train growth a little bit. Before installing cables, you need to have clear objectives for your support systems, and they need to be defined. But I almost want to say that should go without saying, but sometimes people just don't think about that sort of thing. But you always want to have a clear objective as to why is it that you're doing this, because that really might define what it is you want to do. The tree owner should be notified of the need for inspection. The tree must be thoroughly inspected. You want to get rid of any hazardous limbs, because you want to make sure that we've reduced stress as much as possible, and you want the tree to be properly pruned, because putting in a cabling support system but not having proper pruning or not thoroughly inspecting the tree or doing any of these things that we need to do might just almost render the cabling system useless if we don't do all the other stuff that we need to do to make sure that the tree is healthy and happy and living its long extended life. So going back to what I mentioned earlier, the idea of the limbs or trees with less than 30% sound wood should be considered for removal. And so if the tree's not sound enough, if we don't have a good enough place to stick the cables and the hardware, none of it's going to work. And so it's really important that we make sure that the tree is sound enough for the cable to actually work. And so the way you look at it, we have this little graphic here. You've got your X, your Y, and your Z. So the equation for percent of sound wood through bolt applications, you get X plus Y divided by Z times 100 is going to give you your percent of sound wood for through bolt applications. And so that's a pretty easy way of figuring it out. You just got to get some easy measurements and figure out a percentage. No big deal. But the big thing is to understand that if it's less than 30%, then that's not good enough. And if you really think about it, trees or limbs with less than 30%, so less than 1/3 of it is good, is not a lot. So it really makes sense to just at that point to just be considering removal instead. In terms of your cabling hardware, factors that are going to determine your hardware selection. The estimated weight of the limb to be supported is going to be huge, because that's a big thing, is understanding the weight. The diameter of stem at the point of installation, the presence of decay, which we just talked about, and the species that we're dealing with and its ability to compartmentalize. And we went over compartmentalization before, which is that idea of if a wound happens, being able to close off that wound and not allow the decay to continue through the tree. So in going over some of the hardware that's used with cabling, so you got dead end hardware. So this is these are lag hooks. You can also hear a J-lag or a J-hook. Those are all terms that would be used for lag hook. In terms of the dead end hardware, your strength comes from the threads against the wood, and your holes must be 1/16 to 1/8 smaller than the hardware. So when you put in the hole, you want to make sure that you're actually making the hole smaller than the hardware. It should never be placed in decayed wood, and it's for limbs less than 10 inches in diameter. And big thing that the book mentions is the idea of dead end hardware threads must be fully seated. And so you're really looking at this idea of here on the left. You see how you don't see any more of the threading? That's what you're looking for. This and this are not okay. The threads must be fully seated. They must be all the way in there. You can't have any sticking out. I mean, you can, but when we're talking about the idea of we want this to work, we want everything to do exactly what it's supposed to do, we have a much better feeling of that happening here than we do with here or here. In terms of through hardware, you've got eye bolts, you got threaded rods, and you got an Ammon eye. For your through hardware, that's going to be good for limbs over 10 inches in diameter. So we had the lag bolts for under 10 inches in diameter, and we've got the through hardware for over 10 inches in diameter. Strength comes from the tension against the wood, and for the through hardware, the holes may be drilled up to 1/8 inch larger than the hardware. So that's the opposite of the dead end. For the through hardware, the hole is going to be larger, and you can go up to 1/8 inch larger than the hardware. This is good for decayed limbs, right? We still, if we only have less than 30% sound wood, we're still gonna probably suggest removal of the tree. But if you've got some decay and some sound wood, this is a better idea for decayed limbs. The washers, if you're using washers, They must be used under nuts and be seated. So when we say seated, we're pushed right up against the bark. And these are also good for angled installation, as you can see right here and right here as well, that you've got angles, it coming in as an angle as opposed to straight out. When you use through hardware, you want to cut any excess off, and you want to secure peen threads or jam nuts. So you take a ball peen hammer there, and you're basically going to flatten it out so that that nut can't pop off. And if you have excess, you can cut it off. That's another way to do it. Or you can take a hammer and just kind of jam it so that there's no way that that nut can just be pushed off. For your static cable systems, there's 3 types of cable. The book really focuses on the first 2, which are the 7th strand common grade, which is also known as soft lay, and then the EHX, your extra high strength. So your 7th strand is low strength, 1/4 inch, 1,900 pound capacity. It's soft and easily spliceable, so good for tight applications. Your extra high strength is very strong, 1/4 inch, 600 or 6,650 pounds capacity, and it's stiff and it's not spliceable. And then you've got light duty cable, which is used when you're doing small trees and or weight support applications. Thimbles. When we're talking about thimbles, they must be used at the connection of any cable to an anchor. They're going to increase your bend radius. They're going to reduce wear and extend the life of the cable. And you got to make sure to use the appropriate size, and it must be a heavy-duty thimble, because you want to make sure. You don't want to have problems, so use the heavy-duty one. In terms of dead end grips, those are used mainly to attach the extra high strength cable to anchor hardware. Some tools and equipment that you can use to make this happen is a come-along, which is a winch-like device used to tighten the cables and bring limbs together, and then a cable grip or a Haven's grip, which is a device used to attach the come-along to the cable. And you can see an example of that here. In terms of other tools and equipment, so there's a cable aid, which is a tool used mainly to tighten lags, and you can see that right up there. And then a ship auger, which is a type of drill bit that is self-feeding and efficient at extracting shavings, which is extremely important with the idea of we're trying to drill these holes in trees, and we really want to get stuff out so we get a nice clean hole for our equipment to go into. So in terms of installing cables, you've got an eye splice, so that an eye formed by individually wrapping the strands around the cable. And so you can see here, this is how you start with the cable going around, and then you're going to take each individual thread and you're going to just start unwrapping it and then wrapping it up here right around the edge until we got this nice long bundle where it's solid and we're not going to be too worried about what happens because it is locked in there. And so that's the diagram of it, and you can see it actually in what it actually looks like here down below. And this is used to attach your 7-strand common grade cable to an anchor. There's also cable clamps. So cable clamps are used to attach cables of 1/8 of an inch or smaller to anchor hardware. You can see those cable clamps right here. Should use at least 3 per anchor spaced apart. And so you can see a perfect example of that here. 1, 2, 3. And the U of the clamp goes on the short end of the cable. And so if you look right here, we can see there's the short end of the cable. So we want the U part, that part right there, the U part of the clamp to be on the short end of the cable. You can also use wire stops, which I believe with the pictures that we've got here are kind of self-explanatory in the way that they work and stop the wires. There's also wedge grip, which you can see. So here's what it looks like on the tree, and then what it actually looks like when you have the cap off. In terms of cabling installation, one of the big things to remember is that you want to be 2/3 of the way from the branch union to the top of the canopy. And so if we look at our diagram right here, so you can see 2/3 of the tree's height above the crotch right here, that's where we're going to put in our galvanized cable. And in this case right here, we've got a galvanized eye bolt. We've got our thimble right there at the end, a heavy duty one, and then we're using the dead end twist. There's also, in this example here, there's going to be some threaded rods for bracing put into this tree as well. So what does this actually look like in reality? So here is, there we go. Here is your crotch, and we want to be at least 2/3 of the way up the tree from the branch union to the top of the canopy. So our other example here on the right, there's our branch union, and then we're up there 2/3 of the way. In terms of our cable installation, we really want to make sure that with whatever branch union we're going with, we're making sure that our cable is going to be coming from it's going to have a 90-degree angle back to that branch union. So you can see, even though this branch is going off to the side here, we want to make sure that we get that 90 degrees. So our cable has to come in at this angle in order to give us a 90-degree back to that branch union. Also, in terms of our cable installation, anchor hardware must be installed in alignment with the angle that the cable is being installed. And if not, then we can have these problems on the right here where we get the head breaking off. And also important, we talked about the idea of being all the way threaded in. So that's those sorts of things. If we don't have those things happen, it can lead to failure of the system. Another big idea is we only want one cable per anchor. You don't want to put multiple cables on the same anchor. That's just a big no-no. And then if you got multiple anchors on a stem or on a limb, you want to make sure that they're at least one diameter length apart. So if we look at our diagram here, we can see that's the diameter of the limb. So we want to make sure that if this is where our bottom anchor is placed, we're going to go that same diameter distance before we put in our next anchor. And then the other big deal with cable installation is we want it to be taut. And so when we use the word taut, we mean there needs to be tension. We don't want it at full tension. Full tension is like the idea of too much, and we don't want any sag in there. We want it to be tight. We want it to be taut so that it is nice and straight across, but we don't want it to be where it's pulled so hard that it's at risk of breaking. We want it just tight enough. For anybody who's ever had to use like a tow strap with towing a car, that's always for me been the biggest way to understand the idea of taut, because you need that tow strap to be all the way straightened out and flat. But if you just take off with one car and just yank it, you could tear a piece of the car off. Whereas you need to get it nice and taut first, and then you can move the car. And another way to think about it is to think about a rubber band and to stretch out. If you stretch out a rubber band, if you get it to where the rubber band is stretched out and good, that would be taut. But you could keep going with that rubber band. You can keep pulling it to here, but you can kind of see that the rubber band is going to be under too much stress. And if you have the rubber band like this, it would just kind of fall off. So you need it to just be taut to where it's nice and straight, but we're not putting a bunch of stress on that rubber band, or in this case that we're talking about, stress on those cables. We want the cables to do their job without being fully stressed out at all times. So there's different types of cabling. So direct cabling consists of a single cable between two tree parts. So you can see those examples in the diagram below. Those two tree parts could be two limbs, two stems, or a trunk and a limb. You've got triangular systems. So you can see here in our diagram, there's our triangle, and then there's our triangle there as well. And triangular cabling consists of connecting tree parts in combinations of threes. This method should be preferred when maximum support is required. So if you need maximum support, a triangular system is the one that's recommended. And then lightning protection systems in a tree must be bonded to any cables installed in those same trees. So here is a cable that we see installed in this tree. Here's our lightning support system, or lightning protection system, which we will talk about in a little bit, coming down the tree. And then we're going to bond it to the cable right there. In terms of dynamic cable systems, so we talked about static cable systems. So in terms of dynamic cable systems, the support systems are mainly made of synthetic rope. Some incorporate rubber shock absorbers, and some have installation processes that do not wound the tree without anchor hardware. So here's some examples of the equipment used in a dynamic cable system, and you can see the example of the cable system here actually up in the tree, and then a little bit of the climber's perspective down here on the right. In terms of bracing, so with bracing system types, there's 4. So you've got single, you've got parallel, you've got alternating, and you've got crossing. And so if you see single, we just have this one here at the branch union, or just above the branch union. With parallel, you can see all the different braces in this tree that go right along the union. And because they're parallel, they're all in line. If you've got the alternating, you can see that they are a little bit off to either the left or the right, but still the one above the union right there across. And then in crossing, they're coming in at different angles to also help out with the union. When you do bracing, you use steel rods, and so here's just an example of steel rods in limbs, leaders, and trunks. You can see the holes, and you can right there. You can see the steel rod coming through, and you can see it there and there on that one as well. So in terms of when we're looking at bracing, you want to determine the number of rods by measuring the diameter below the junction, and then you want to install at least one rod above the junction, which we saw in our example of the 4 different ways we're gonna brace. So here is our 1 rod above the junction, and then we're gonna measure right here at A. We're gonna measure to determine above the crotch rod height. So we figured out A, so that is 1 times A and 2 times A. So that's where we're gonna put that upper rod. Is we're gonna go at least 2 times the diameter of the codominant stems, or the trunk and the limb, whatever it is that we're bracing. And then we're going to measure here at B, we're going to measure the width of the full stem to determine the total number of rods. With bracing, we're going to use lag threaded rods, and the strength comes from the threads, just like the J lags or the lag hooks that we were talking about before. You want to drill all the way through the small side and at least halfway through the smaller stem, which you can see right here in this picture. The idea of we want to get at least through halfway. You can also use machine threaded rods, and for machine threaded rods, the strength comes from the tension on the outside of the wood against the washer and nut, just like through bolts. And we're going to have that same procedure with the idea of making sure that we peen that end so that the nut doesn't come off. So in the ANSI 8300 manual, it has a chart where it shows you how to determine the size and number of rods for bracing. So we talked about measuring the diameter at brace, and that lets you know the idea of how many rods we want to include. So here it's with split or included bark. And then if you have no apparent split or included bark, how many you need. And in terms of our diameter, we've got all the way from less than 5 inches to greater than 40 inches, which covers all the trees. So we've covered cabling, we've covered bracing, and then we've got guying. So guying is the supporting of one tree with another tree or a ground anchor. And the place that I see guying the most, or that it makes the most sense to me, is just the idea of telephone poles, power poles, those sorts of things. You'll see are guyed all the time, usually. The cable should be installed in the bottom half of the anchor tree and above the midpoint, preferably 2/3 of the way to the top of the tree, in the tree being supported. So you can see right here that if we're going to go tree to tree, the tree that we want to support needs to be supported up high, preferably 2/3 of the way to the top, but at least higher than half. And then the one that's going to be our anchor tree, we want it to be lower than half the tree height. Here's a nice picture of a tree that is being guyed down. And this one's not tree to tree, but you can see right here we've got an anchor. We got our cable, and we've got an anchor down here at the bottom in the ground. And this one has 3 points. I don't see a 4th point, but I see 3. So kind of wrapping it up on tree support systems, cabling, bracing, and guying systems will provide additional support, but they do not make a tree safer. We're just trying to extend the life of the tree, and we're trying to reduce the potential for catastrophe. Your ANSI A300 standards are they're the standard that dictates how these systems must be installed, whereas the best management practices are the how-to guide based on what you learn. So basically, you take the ANSI A300, and it's going to say this is how it's got to be installed, and then the best management practices is your how-to guide for that. All right, so this is what I need to do. All right, how am I going to do that? And that's how you work with both of those manuals. Limbs over 10 meters or limbs over 10 inches in diameter need through hardware. Anchors always need to be in alignment with the cable, no side loading, and your lag hardware needs to have all the threads fully seated in the wood, because we don't want that head just snapping off. You always want to have all of the threads all the way seated in the wood. So in terms of lightning protection, so I've got a nice little video here. So if you want to pause the lecture right now and click on the link in the notes, that will take you to a video explaining lightning protection. So go ahead and pause now. So in terms of lightning protection, our big 2 ideas are to protect important trees, and we really want to reduce the risk of side flash. And what side flash is the idea of basically a tree being hit by lightning, and then that lightning being able to jump over to a structure. And so if you have a tree that's within 10 feet of a structure, they're going to usually suggest some sort of a lightning protection system, because we don't want it to jump over to the house or the structure and cause damage to the structure. there's three big pieces to a lightning protection system. So you got your air terminal, which you can see, there's my mouse, which you can see right here. It's the uppermost point of the system, and it's usually made out of copper, because copper is really good at conducting. You've got your main conductor, which you can see here attached to our air terminal going down that way, and that's a copper conductor connected to the air terminal that's running down the trunk to the ground. And then one thing to remember is that wide-spreading trees, you may have to have more than one air terminal if the tree has a really wide crown, and then multiple leads are going to be connected at the main trunk. And so you can see that there. And then in terms of our ground terminal, which is our third part of our lightning protection system, here's an example with a ground rod, which is an 8-foot long copper rod driven into the ground. And you can see that there. Here's the idea of the connection point. And then I've got right here another video to watch, so go ahead and pause right now and take a look at that. And so the big thing with lightning protection systems is they're there to help redirect the electrical charge. And it's really important for me at least, is the idea that that lightning still has a role to play in nature. We just don't want lightning to cause us big problems or big issues, but lightning is important. It's one of the ways we do nitrogen fixation. So having lightning and having it hit the ground and hit the soil is not a bad thing. It's actually a really good thing, because it helps us fixate nitrogen and change nitrogen into a usable form in the soil. So it's actually a great thing to have the lightning hit the ground. We just don't want it to hit trees and bust up trees that, you know, send shards and pieces flying, and we definitely don't want it hitting a tree and then bouncing to a structure and causing a bunch of damage. These lightning protection systems do not prevent a tree from being struck by lightning. They're just trying to get the charge to not go through the tree and instead go kind of past the tree and into the ground, or at least not have the tree accept the whole charge, have some of the charge be sent down to the ground without the tree having to take the whole brunt of it. Our ANSI A300, those are our industry standards that dictate how the lightning protection systems will be installed. And then the ISA also has a best management practices how-to guide, just like for the tree support systems. And that's what I got. So hope you liked it. And if you have any questions, just let me know.